Obviously, if we have the graph, those two functions are inverses if they are reflections of each other over the line y equal to x. Algebraically, we have three choices, mostly, to show that they're inverses of each other. One is the composition. The left composition is equal to the right composition, and it's equal to x. The second is to show that the inverse of f of x is equal to g of x. The third one is to show that the inverse of g of x is equal to f of x. So we can choose one. The first one, the left composition is equal to the right composition, and it's equal to x. F of g of x is equal to f of g of x, which is cube root of x plus 1 over 2. Which means that whenever we see x, we're going to replace it by cube root of x plus 1 over 2. So it's going to be equal to 2 cube root of x plus 1 over 2 cubed minus 1. Now, cube will be just the radicand, so it's going to be 2 times x plus 1 over 2 minus 1. 2 cancel, so it's x plus 1 minus 1, which is equal to x. Let's consider the left composition, g of f of x, and f of x is 2x cubed minus 1. So it's g of 2x cubed minus 1. Wherever we see x, we're going to replace it by 2x cubed minus 1. So it's going to be equal to cube root of 2x cubed minus 1 plus 1 divided by 2, which is cube root 1 minus 1 is 0, 2x cubed over 2, and 2 over 2 is 1, so it's cube root of x cubed, which is equal to x. So we just show that the left composition is equal to the right composition, and it's equal to x. For b, we're going to start with f of x. And f of x is equal to 2x cubed minus 1. We're going to show that the inverse of f of x is equal to g of x. Now, y is a function of x. We replace f of x by y. Y is equal to 2x cubed minus 1. Swap y for x. X is equal to 2y cubed minus 1. Add 1 to both sides. X plus 1 is equal to 2y cubed. Divide by 2. We get y cubed is equal to x plus 1 over 2. Now, y will be equal to cube root. We take the cube root of both sides. Cube root of x plus 1 over 2, which is g of x. So the inverse of f of x is equal to cube root of x plus 1 over 2. And we know that g of x is cube root of x plus 1 over 2. Therefore, the inverse of f of x, is equal to g of x. The third way this could be done is to start with g of x. And g of x is equal to cube root of x plus 1 over 2. And we're going to prove that the inverse of g of x is equal to f of x. Y is equal to, replacing g of x by y is equal to cube root of x plus 1 over 2. Swap y for x. X is equal to cube root of y plus 1 over 2. Cube both sides. X cubed is equal to y plus 1 divided by 2. Multiply both sides by 2. 2x cubed is equal to y plus 1. Subtract 1 from both sides. 2x cubed minus 1 is equal to y. So the inverse of g of x is equal to 2x cubed minus 1. Now we know that f of x is equal to 2x cubed minus 1. Therefore, the inverse of g of x is equal to f of x.